All right, welcome back. So we're going to do another pumping problem. And it's this problem here. We've got a tank. Note that the spout is up at the top. And looking at these 3D pictures, it can be a little bit tricky, but the top is actually flat. So the whole tank is kind of at an angle. And so in fact, what might be helpful if I drew in a side view of this problem, the side view of this problem is going to look something like this. Okay. So the side of that tank is going to look something like this. This is going to be 6. This is going to be 12. And what we're drawing in, down here in the second picture, you can see I've drawn in, maybe let me even do it in red. I've drawn in what a slice of water will look like. So we have a slice here. And I can kind of draw that in up here as well. And so this slice is going to be a rectangle. And let's say it has thickness delta x, like we always do. So what's changing in this rectangle is the width over here. So this width, w, can of course get bigger and smaller. And so let's label it in over here. So we now have this kind of side view that's going to be helpful for us. And already we can sort of work things out, right? We have our volume of our slice is going to equal, let's see, this side is 10, this side is w, so it's going to be 10 times w times delta x. Okay, so let's going to put that in a box for a second. We know then that we also have to care about the distance that our slice is traveling. So let's kind of include that here, maybe in blue. So this slice is going to travel all the way up a distance of x to the top. And let's go ahead and label that in here. Let's move that out. Let's label this distance here x, which is going to mean that this distance down here is 6 minus x. And yeah, now let's just think big picture. Let's just think about what our integral is going to be. So our integral is going to be force times distance. So force is going to be in pounds. And then we're going to have to multiply that by our distance, which is going to be in feet. Okay. And so far, we've set it up so the distance that our slice is traveling is going to be x. So that's going to go in there. So we're going to put our distance is going to be x. And then our force, well, that force is going to be our volume. So volume is going to be in cubic feet. And then if we multiply that by 62.5, which is the density of water, then that's going to convert our volume in cubic feet to a weight in pounds. Okay. So very good, very good. And so now all we have to do is, it looks like x is going to be our variable. And the only thing we have to do now is get w in terms of x. Okay? Because then if we can do that, we're going to be able to take our volume and plug it right in here. We'll get everything in terms of x. That delta x is going to turn into a dx, and we're going to be in great shape to use that integral. Okay? So let's do that. And so, yeah, so to do that, we're going to look at our picture up here. So I'm looking at this triangle in the upper right. And I just see I have two similar triangles, right? So on the big triangle, I have something that's 6 by 12. And on the smaller triangle, I have something that's w by 6 minus x. And so what must be true if I divide, say, the top by the side? That's got to be the same for both triangles. So whether I do that with the 12 by 6 triangle or the w by 6 minus x triangle, I should get the same thing. And when I solve for w, I get 2 times 6 minus x. And I can now plug that back in to my formula for volume. So the volume is going to equal 10 times 2 times 6 minus x dx. Again, that's my picture here. This red box I've just substituted in for w. Okay. So let's go ahead and put everything together. Let's move this apart a little bit. Get rid of this stuff down here. And for our volume, what we're going to do is we're just going to write that in. So we're going to get 10 times 2 times 6 minus x. So that's going to be 20 times 6 minus x. That delta x is going to become a dx. And now all we have to do is think about what x is ranging from. So x is the distance from the top. Well, the distance from the top could be 0. Or the distance from the top could go all the way down to the bottom. And since this whole thing is 6 feet tall from our original picture, our bounds are going to be 0 to 6. And so if I work this integral out, I'm going to type that into Desmos, and hopefully I remember what we have, Desmos. So I'm going to type it in. I'm going to get the integral from 0 to 6 of, let's see, 20 times 6 minus x times x dx. Oops, and there was also a 62.5. Let's just put that in there. Times 62.5, and then a dx, I'm going to get 45,000. So this value here is going to be equal to 45,000. And since we're in the US system, our units are going to be foot-pounds. So that is how we set up these problems. As always, I recommend you now maybe start the video over, start with a blank sheet of paper, and see if you can do all of these steps. And if you have any questions, please comment, subscribe, and let me know if you have any questions. Thank you. Bye.